Hi my friends, my name is Selim.Digital. My students call me Mr. T, and this is a couple of minutes of science. My goal is to basically get the lab experience that my kids have down into a couple of minutes so that you can get the most important part of the science, which is the actual exploration of the beauty of the world. All right, so we have here alcohol. Woohoo! Not the kind that you drink. 70% alcohol, 30% water, and we purified it to 95% alcohol. We're doing that not for a party, but for exploring the idea of combustion, meaning fire. Chemistry fundamentally began with the understanding of fire. The first chemists were cooks, and we need to understand fire if we really want to understand heat, if we really want to understand the world that we built. We couldn't have built it without fire, so we need to really understand it. All right, so we've got 70% alcohol here and 95% alcohol here. You know why chemistry is so awesome? Because it gets lit. All right, let's take a real serious look at what we've got here. You can see a difference in the fire. We can see that the flame is getting significantly higher at the 95% alcohol, much lower at the 70% alcohol. We also see differences in the color. This is a much brighter orange. There also seems to be more smoke coming off, or at least from my end, from here. Now, it looks like it's just one fire, but that's not actually what's happening. These tongues of fire are actually separate fires. It's just that our brain is seeing them all as one fire. But if you took like a rapid camera, you would see individual flames sort of coming together. And the reason for that is oxygen is coming in and interacting with the alcohol and breaking down the alcohol, C3H8O, into carbon dioxide and water. And that is fundamentally, whenever we combust something, whether it's paper, whether it's alcohol, whether it's gasoline, what we're doing is we're releasing heat energy, light energy, and the actual matter that makes up the alcohol is transformed primarily into carbon dioxide and water. Yes, there's sometimes other byproducts like methane, depending upon how complete the combustion is, but when it completely combusts, you see that the end byproduct should be primarily carbon dioxide and water. If there's other things in it, then those would be left over. Like if you have ash in a tree, that's left over byproducts that were not ultimately carbon, hydrogen, and oxygen. All right, so we're seeing the flame is different. It's dancing around differently because there's differences in how the oxygen is interacting at these particular spots. We're seeing a difference in height. We're seeing a difference in color. All of that is a result of the amount of water and alcohol in each of these samples. All right, it's getting a little warm in here, so we're going to put this out. So, why did that work so quickly? Because fundamentally, without oxygen, there is no fire. Oxygen is what is breaking down the alcohol in this case. So once I immediately suppressed the access to fresh air, to fresh oxygen, it ended the burn. This is why a blanket, when you have a fire, can put out a fire. You're essentially cutting off the fuel supply, the oxygen supply, that is allowing the combustion to continue. All right, this was a couple of minutes of science. Hope you had fun. I know I did, because I love fire.